Hello everyone, my name is Patil and I am from RBNB College, Shirampur. As in previous videos, we were studying about one of the important chapter from 11th standard, that is elements of group first and second, means the alkali metals and alkaline earth metals, in which we have seen their electronic configuration and which kind of trends they show along the group. As we know that the elements belonging to the same group exhibit the same properties, or that may be physical properties or chemical properties, just there is a small gradation. Means what? There is a slight change between their properties while going down the group. But now we'll see, moving towards the next, the chemical properties. What are the chemical properties that exactly alkali metals and alkaline metals shows? As we know that alkali metals belonging to group first and alkaline metals belonging to group second, they show highly reactivity in our modern periodic table, as their ionization enthalpy is low. Why? Because as the atomic radius increases, the number of electrons present in the outermost orbit of these alkali metals and alkaline metals is just 1 and 2 for the group first. It is only 1 electron present in the outermost orbit, and for the group second there is only 2 electrons are present. Means what? The ionization enthalpy, or the energy required to remove that electron from that atom, is lowering as the atomic radius increases down the group, and that's why their reactivity, they are highly reactive in nature. All these are the metals, and due to this, these metals exhibit in the molecular state or in a combined state. They are not in free state. They do not occur in the free state. Now we'll see some important chemical properties. As we know that these metals are highly reactive, let's see some important chemical reactions. Means what? Like reactions with the oxygen, what they react with, how they react with the air or oxygen. With the reaction with the water, what kind of reactions they give with the water, and reaction with halogen atoms, means that elements belonging to group 17. As these two groups, group first and group 17, or group second and 17, they are exactly opposite in nature. As these are the highly reactive metals, they are the highly reactive non-metal halogens. Here only one, that ionization enthalpy of the group first element is lower than the ionization enthalpy of the group 17th element, as the number of electrons present in their outermost orbit, or number of electrons required to fulfill their octet, is higher. Okay, now let's see the reaction with oxygen. Reaction with oxygen, or we can say that air, the presence of oxygen is in the air. That elements of group first, like lithium, sodium, potassium, they react with the oxygen or they react with the water. As their highly reactive nature, they give the corresponding oxides. Means if lithium, when it reacts with oxygen, it gives formation of lithium oxide. This one is lithium oxide, or the element. Now moving down, reaction of sodium with the oxygen gives sodium peroxide. Instead of formation of sodium oxide, when sodium reacts with air, or when sodium is reacted in the air, it gives that formation of sodium oxide. And potassium, it also reacts with oxygen. Forming potassium superoxide. Why is the difference between these elements? Due to their reactivity, and as the number of orbit increases, the reactivity of corresponding metal, that is the lithium, sodium and potassium, goes on increasing. All these three elements, or these three metals, belong to group first. In case of group second, we can say that magnesium, calcium, they react with the oxygen, forming their corresponding oxides. likewise, as we know, both the elements means what? Which elements? That oxygen and alkali metals, that may be the magnesium, that may be the calcium or cesium. These all metals, their valence is 2, and as we know that oxygen is capable for the fulfilling these valencies, and that's why when magnesium reacts with the oxygen molecule, forms magnesium oxide. These are the magnesium oxide. That formation of oxide, we can say this is the decomposition of a metal. Their reactivity decreases when they react with the oxygen or they react with the, that we can say, when they react in the air. Another important property of that magnesium, when it reacts with the nitrogen, when it reacts with the nitrogen, forms the magnesium nitrides. This one is the nitride product of the magnesium. When magnesium reacts with the nitrides, gives magnesium nitrides. Means what? This reaction is also carried in the air or in presence of oxygen. That's why this property is included in the chemical property of the group second elements, reaction with the oxygen or air. When magnesium, it reacts with the nitrogen, forming the corresponding nitrides. This was the reaction of group first and group second with the oxygen. Now, reaction of these group first and group second element with the water, we can say, as group first element and group second element, as we are discussing, they are the highly reactive. That's why when they react with the water molecule, that water molecule decomposes and there is a formation of metal hydroxide, and this kind of reaction, these are the highly exothermic reactions. Means what? The heat is evolved during the reaction of these alkali or alkaline metals with the water. It is a highly exothermic reaction. We can say that there is a formation of hydrogen gas or the bubbles of hydrogen appears, and that's why when these metals like sodium, okay, we can see hydrogen gas, it is evolved. Means what? These hydrogens, they forms bubbles. They forms bubbles in the water molecule, and that's why these metals, means that can be the sodium, that can be the potassium, when they react with water, there is a formation of hydrogen gas or the bubbles of hydrogen, and due to that they float on the water surface. These were the reaction. Especially we can note about the group first element, and in case of group second, we can note that when group second elements, that may be the calcium, with the better known example of calcium. When calcium, it is reacted, or let it be react with the water molecule, gives this is a precipitate. Means what? When calcium reacts with a water molecule, there is a formation of calcium hydroxide. And in the form of when it reacts, that calcium metal reacts with the water molecule, forming the precipitate, which can be stored or which can be located at the bottom of the whatever the solution we are taking or the reaction we are taking in the which vessels. Okay, and here again that hydrogen gas is evolved, that is a formation of bubbles, and these reactions are highly exothermic. Means we can note when we are going to prepare that, or in the lab during the laboratory practice, if we react these metals with the water molecule, their formation of their corresponding hydroxide is the form, but reaction is highly exothermic. Means what? If we are conducting this reaction in a beaker, that is the beaker get hot due to that exothermic nature. Okay, and due to their this property, that formation of hydroxide and exothermic reaction, these metals generally do not stored in the water. Instead, they are stored in any other organic solvents or the other solvents. Okay. Now the reaction with the hydrogen, as we know that hydrogen, the position or the location of hydrogen could not be established in the modern periodic table, as we are putting it on the top of the group first element, but sometimes it shows the properties like the group 17th element as a formation of hydrides. Means what? Whenever these metals reacts with the hydrogen, there is a formation of metal hydrides. There is a formation of metal hydrides where hydrogen acts as an electron acceptor. Where hydrogen acts as an electron acceptor, forming the corresponding metal hydrides. Now, the main reaction, what is the important and crucial reaction about this group first and group second element? These are the reaction of these metals, which alkali and alkaline metals with the halogens. Reaction with the halogens. What kind of reaction they show with the halogen? As we know that the highly reactive metals of group first and highly reactive non-metals of group second, group 17, that is they are halogens. When they react, there is a transfer of electron, or there is a complete reaction, and these reactions are redox type of reactions where the product is corresponding metal halides or salt of the halides. Means what? These metals, whatever when they reacts with the halogen, this is the general reaction, there is a formation of, here M represents the metal alkali metals, X we know that halogens, and these are the metal halides or salts. There is the formation of salt. Means let's take an example. When sodium it reacts with the chlorine, there is a formation of NaCl. We know very common, we are familiar with this NaCl, that is a common salt, we are edible. And another for the group second elements, as group second elements they require two electron donor, two electron acceptor, as they have two electrons in their outermost orbit. That's why these metals also, which that these are the group first. In case of group second, we can note when the elements of group second they reacts with the halogens, they also form the corresponding metal halides, but there is a slight difference between the group first and group second. That is the reaction of magnesium with the Cl2. We can note magnesium chloride, as there the valency is completely fulfilled. Like these reactions are shown by the different kind of reaction are shown by the elements of group first and second. Just we have to note that these elements are highly reactive due to what is the reason behind that? That the lower ionization enthalpy, as there is a presence of only one or two electrons in their outermost orbit, the amount of energy required to remove that electrons will be the low as compared to the other elements, and as the atomic radius increases. As we have seen the trend in the periodic table, moving down the group, for the every group moving down, we note that the atomic number or number of orbit increases. That's why the atomic radius also goes on increasing, and as the atomic radius or atomic ionic radius goes on increasing, there is a slight or gradation in the ionization enthalpy. As we can see that the ionization enthalpy also goes on decreasing while going down the group. These were the chemical properties. Now there are some important products or compounds we have to study in the of group first and second, and the diagonal relationship we will see in the next lecture. But just remind that what is the diagonal relationship. Diagonals means they are exactly crossed, their position is exactly crossed along the diagonal, where as we can see in the modern periodic table that the elements belonging to the same group have similar properties and there is a slight gradation. But instead of that, so there are few elements like lithium and magnesium, beryllium and aluminium. They show there are some similarities in their chemical properties and their physical properties also. What are these similarities? What kind of relationship or diagonal relationship they show? Now moving toward the first point, that is diagonal relationship. What it means, the diagonal relationship? As we know that elements in the modern periodic table have been classified according to their increasing atomic number and with the help, that is the periodicity, in their physical and chemical properties. Means what? Those elements which belong to same group will exhibit that they will show some similarities and gradation in their properties. Means what? There are few properties like atomic radius or ionic radius or ionization enthalpy. They gradually changes. Means somewhere they will increase, somewhere they will decrease, but along the group, and maximum they will have the same properties. Means what? Those elements present in the element group first, they are called as, they all are alkali metal. Elements belonging to group second, they are all alkaline earth metals. This is the general concept we can expect from the modern periodic table, but there is an exception for two elements. Those are lithium and beryllium belonging to group second, period second, and third one, that is the sodium, magnesium and aluminium. What is the diagonal relationship? Look here, this lithium and magnesium, beryllium and aluminium, these elements are present on a diagonal. Generally, we can accept that lithium will show, or it has to show, similarity in properties like the sodium or potassium, cesium, what may be the next element that is belonging to the same group. But instead of showing that properties like alkali metals, that the first alkali metal, that is lithium, resemble in properties with the properties of magnesium, means that maybe the reaction of lithium with oxygen or formation of oxide, metal oxides, or reaction with the carbon monoxide, that formation of nitrides also and monoxide also. What it means, that lithium will show the reactions or properties like the element magnesium, which is present in the next group, that is it is an alkaline earth metal. And in case of beryllium, it has to show that properties which similar to the alkaline earth metal, but instead of that, beryllium shows the properties same or similar like the aluminium, that is the next main group element. As we know that the elements belonging to group first, second, and from 13 to 18, these S and P block elements, or these groups are known as main group elements. These elements are main group elements, and that's why this is a diagonal relationship between that alkali metal lithium show the properties like the alkaline earth metal magnesium, and beryllium will show like the aluminium. These are the diagonal, they present on a diagonal, and that's why the relation between their physical properties, it is a diagonal relationship. Now instead of uses, what uses we can see that lithium, we are that uses of elements, uses of elements of group first and second. What are the uses? Let's see one by one. That for the group first, where the very first element is lithium, which is generally used for preparation of long life batteries, which are used in the clocks, computers, and many digital watches. Means what? The digital batteries that made up from the lithium. Again, second element, that is the sodium. That liquid sodium metal is very much useful in case of at the nuclear power station, as it is used for the transfer of heat. Liquid sodium. Okay, another, that potassium when it reacts with the chlorine, formation of the potassium chloride, which is a very good fertilizer. Again, that potassium is also used for the formation or preparation of potassium superoxide. In case of elements belonging to group second, beryllium is also used as a moderator in a nuclear reaction or a nuclear reactor. Okay, again the alloys of that aluminium and magnesium. What are the magnesium and aluminium? They are the metals, and their alloys, they are used mainly as a structural material or skeletal material used for the preparation of that skeleton of the aircraft. Okay, these are the different uses of elements belonging to group first and second. Now we'll see the two very important compounds that are formed from the elements of group first and second. That is the one of them is first is caustic soda or sodium hydroxide. NaOH, that is the caustic soda. We will see that sodium hydroxide or sodium hydroxide, it is generally obtained by the electrolysis of a sodium chloride solution. Electrolysis of a sodium chloride solution means what? If that solution of a sodium chloride is provided with the electricity, means there is a use of two electrode, one will be the anode, different will be the cathodes. That cathode electrode or cathode rod, that mercury, it is used as a cathode, while carbon rod, it is used as a anode. As we know, cathode is a positively charged, anode is a negatively charged. That negatively charged rod is made up of carbon, while the cathode is sodium. That reaction, it is carried, or this is the barium solution which is introduced in the Kastner and Kellner. Kastner and Kellner cell. Kastner and Kellner cell, in which cathode will be the that mercury and anode will be of carbon. Two different reactions that are separately carried on the cathode and anode. At the cathode, what will be the reaction? That cathode will lose the electron. Which electron? That sodium. Reaction at a cathode will be the sodium ion will lose the electron forming sodium amalgam. It is known as sodium amalgam. And at the anode, as we are introducing the solution of sodium chloride for the electrolysis, that chlorine reaction will take place at the anode, that is the chlorine molecule. There is a liberation of chlorine gas. Liberation of chlorine gas. And this sodium amalgam further on hydrolysis, simple hydrolysis, when it is introduced to the hydrolysis, it is get converted to our desired sodium hydroxide. What are the properties? It is a deliquescent solid which has the ability to absorb the moisture with the melting point 519 Kelvin temperature. What is melting point? Melting point is 519 Kelvin. 519 Kelvin. The major use of this compound, which is the sodium hydroxide, it is used for the synthesis or commercial preparation of a soap. Commercial preparation of a soap. This for solution means what? As this sodium hydroxide, it is highly soluble in water. That's on the surface. That surface is deliquescent, as we are saying. Means what? That atmospheric carbon dioxide, it will absorb for the formation of sodium carbonate. For the formation of sodium carbonate, and that's why it is used in the soap preparation. Okay. Now the next element, which is used very largely in the chemistry or in the organic chemistry as a reducing agent, that is lithium aluminum hydride. Second one, lithium aluminum hydride. In short, it is named as LaH. Lithium aluminum hydride. Generally, this lithium aluminum hydride is prepared. How? By using or by reaction of that lithium hydride with aluminum chloride. There is a formation of here LiAlH4, and that chlorine is given out. Here in this reaction, we should know that lithium aluminum hydride or LaH, it is violently reactive with the water, which gives the highly exothermic reaction, and mainly lithium aluminum hydride is used as a reducing agent. It is used as a reducing agent, as there is the addition of hydrogen. It carries 4 hydrogen, it will donate the hydrogen. Reducing agent for the major synthesis. Means what? Generally we can see that this is the ester. This is the ester. When it is reduced by using lithium aluminum hydride in presence of a dry ether as a solvent, what will be the reaction? What will be the product? The product will be RCH2OH. Means what? This lithium aluminum hydride is a strong reducing agent, and this lithium aluminum hydride, it is made or it belongs to the elements of group first and second. Here, this was a short introductory part about the elements of group first and second. Rather, there are different properties and many unseen properties of elements of group first and second. We'll have discussion about that, but for now we'll stop here.